Welcome back, everybody. So today we're going to talk about combinations. Combinations is just short for saying, hey, I want to take a group of something and I want to figure out how many different ways I can arrange that. So what's different about combinations is that when I grab a group of something, I don't care about the order in which I grab it. So that's going to be key to these problems. Order doesn't matter. So situations that involve taking combinations of stuff where order doesn't matter might involve selecting groups of objects, maybe a committee of people, and like I said earlier, objects as well. So these are different types of situations where I don't care about the order in which I look at an arrangement. All right, let's take a look at an example, and that'll probably be our best bet. So example number 1. Let's say we have 10 people, and you want a group of 3. Well, just like we did in the previous lesson, right, I need 3 people. So 1, 2, 3. So I have 10 people, and I don't want it repeats here, times 9 times 8. Except what's different in this situation, as I've said earlier, order doesn't matter. When I take this problem, order does matter. So I've got to divide out all the different ways that I can arrange these 3 objects. Well, if I list those out, there are in fact 6 ways, or 3 factorial ways. So this just comes out to be 10 times 9 times 8 divided by 3 times 2 times 1. And if you just use a calculator, you'll get 120. All right, so going through this isn't that big of a deal every single time unless this number gets big. So what we really want is a formula. So the formula for this would look something like this. N choose R. And in fact, there's 2 ways we're going to take a look at solving it. All right, where N stands for the total number of objects or items, in this case people, and R is the amount you want, or the desired amount. So for this, I have 10 choose, I'm choosing 3, and that's what that C stands for. It stands for choose, and that's how we read it. So the formula looks something like this. It's going to be n factorial divided r factorial over n minus r factorial. Now remember, n was just 10, r is 3, so I can substitute all those numbers in there, which comes out to be 10 factorial over 3 factorial times the quantity 10 minus 3 factorial. Now I can multiply that out. 10 times 9 times 8 times 7 and so forth. 3 factorial is 3 times 2 times 1. This is just 7. 10 minus 3 is 7. So 7 factorial looks something like that. Now you might be thinking, oh my gosh, this is a lot of work. But what's kind of nice is a lot of stuff cancels out. So look what I end up with. I end up with that idea that we started with, right? Which is, we've already solved to be 120. All right, so now if my numbers were a little bit different, I would just change the numbers around here. And the disadvantage of listing it out to begin with was the fact that if this number or group of, let's say, 8, then I'd have to list a lot more numbers out. Now, there's always a better method, which is using a calculator. I don't know if it's better, it's definitely more efficient. So the way you use that in the calculator is we are going to enter it in directly the way we see it. Oops, and choose 3, sorry. So where you would find that is, oops, let's go ahead and clear. You hit math, and we're going to go over to probability, and we're going to go down to number 3. You're going to see that N choose R. hit enter, and we're just going to put the number 10 and the number 3 in there. So that's what you should be able to see on the calculator. In fact, if you have a calculator, look for nChooseR on your calculator, and you can use that button as well. Right, so then it just pops out with the answer, 120. You could also Google it. You actually just type in 10, choose 3, and you can use that right on a computer. So if you have internet, you could just type in 10, choose 3, and a computer or a calculator will pop up and it'll give you 120. All right, let's look at another example. So let's say Mrs. Kohler wants to have 16 kids. And she wants to have 16 kids so that she can have her own soccer team. So a soccer team needs 11 players. So her question is, how many different groups of 11 players could she create? So what are the number of different teams she could create? Assuming that position didn't matter. She's going to let them play wherever they want. All right, so the first thing you want to take a look at is what's the total number of people or total number of objects? Well, she has 16 kids, choose, and she wants a team of 11. So it's going to be 16, choose 11. Now you choose whatever method you want, but at the end, you should have 4,368 different possible teams she could create. All right, our third example. Let's say we want to play a card game, poker. So in the game of poker, you play with a standard deck. Just if you don't know, a standard deck has 52 cards. There are 4 suits. The suits are diamonds, hearts, the spade, and the clubs. And there are 13 in each suit. And they range from ace, 2, 3, all the way up to 10, jack, queen, and king. And sometimes these are referred to as face cards because they have faces on them, the jack, queen, king. So my first question is, how many 5-card poker hands could be created? Well, again, you start with the total possible objects. So you have 52 cards. And within those 52 cards, you are choosing 5. And in fact, there are 2,598,960 poker hands. All right, my next question then is, in the game of poker, there's different arrangements that are worth more than other arrangements, and one of those arrangements is called a flush, and that's when you get 5 cards of the same suit. So how many 5-card hands in the same suit? And again, those are called flushes. Right, this one's a little different. So I want to get them in the same. So let's pick a suit. Let's say diamonds. So how many diamonds are there? Well, there are 13 diamonds, right? 13 cards in each suit. And I want to have 5 of them. But wait, I don't just have to get a flush in diamonds. I could also get a flush in hearts, in spades, and in clubs. So since there are 4 suits, I'm going to take that answer and multiply it by 4. That answer comes out to be 5,148. So another one that you could figure out on your own is figure out how many different lottery tickets would you need to buy if you want to cover every single possible combination. And you do it exactly the same way. How many different numbers, and then how many different possible numbers could I choose from? And then how many numbers are actually chosen to win the lottery. All right. Thanks for watching.